This is video number 1 for filling in the unit circle. This is one of my favorite lessons that we do all year because most of what we do in trig is focused around the unit circle, at least for quarter 2 and quarter 3. It will be helpful to you if you have some highlighters. It would be great if you had 3 different color highlighters. That would be preferable. If not, you can do this lesson without highlighters. So the first thing you're going to want to do is draw a circle and do those 4 corners. So we are going to start off when we fill in this unit circle. The goal is to be able to fill in this unit circle without having to look at anything, without a calculator, without anything else. So when I originally draw my circle and I have my 4 corners, I know that this is 0 degrees, this is 90 degrees, 180 degrees, 270 degrees, and back to 360 degrees. So sorry if you can't see all of that. Can we see all of it? I think so. All right. The next thing I'm going to do is I'm going to go ahead and fill in my radians. I know that this is 0 radians, and I know that this is 2 pi, because I know that, oops, sorry, it's going to be a squiggle. I know that 2 pi is the equivalent of 360. Well, if this whole circle is 2 pi, then half of the circle must just be pi. And then half of a pi would be here, pi over 2. And then down here would be 1½ pi, or 3/2 pi. Then I'm going to go ahead and fill in my ordered pairs here. I know that this center of the circle is 0, 0, and this is 1 unit over, so this is 1, 0. Up here at the top would be 0, 1. Over here on the left would be -1, 0. And again, it's because this is 0, 0, 1 unit over, 1 unit up, 1 unit left, 1 unit down would be 0, -1. Okay. Next, what I'm going to do is I'm going to go ahead and fill in, because we have to remember that on our unit circle, all of our ordered pairs are, oops, sorry, started to write that incorrectly. I wanted to say that all of our ordered pairs are always in the form cosine of theta, sine of theta. So in every one of these instances, I've got cosine and sine. If you know that you are going to mix up that the first coordinate is cosine and the next coordinate, the other coordinate is sine, then you should go ahead and you should write that underneath of each one. On every single one of these ordered pairs, you'd want to write cosine, sine, cosine, sine, cosine, sine, cosine, sine. If that's something you need to do, pause the video right now and fill that in. If you know you're going to forget otherwise, I would pause the video and make all my x coordinates cosine and all my y coordinates sine and just write that underneath. You should do that right now. And then what we're going to do on the outside of every one of these ordered pairs, we're going to eventually be filling in tangent. But what I want us to fill out now is that, like for instance, in this quadrant 1 here, everything, this is my positive quadrant, and then my tangent is going to be sine over cosine. So I'm going to write that right up here now as a reminder. Tangent is sine over cosine. And so what I'm going to do is I'm going to write my tangent on the outside. Now, unfortunately, with these ordered pairs here and here, I don't really have room, so I'm going to have to put it underneath. So sine over cosine is 0 divided by 1, which is 0. This is 1 divided by 0, which is undefined. This is 0 divided by -1, which is 0. And this is -1 divided by 0, which is undefined. So on the outside of every ordered pair, I'm going to write what the tangent is. So the tangent is always written on the outside of the ordered pair. All right. Now, the next thing that we have learned is that we have corresponding angles. We have what we call a reference angle and then all corresponding angles. So I'm going to get my first highlighter. I'm going to use pink for my first one. And for this first line, I'm going to highlight it in pink. And I'm going to highlight the other one that is the same distance away, which means all of my angles and ordered pairs that are on my pink lines should correspond to one another. I'll show you what I mean. This first angle is 30 degrees away from the horizontal, which means if this is 30 degrees away from 180, this would be 150. And remember, as we go along this straight line, we can add 180 to 30, which gives me 210 degrees. And I can add 180 to 150, and I would get 330 degrees. Notice they're each 30 degrees away from the horizontal. An extra 30. Okay? Now what I'm going to do is I'm going to figure out my radians for these degrees. So if this is 30 degrees and I want to figure out my radians, I've got to think to myself, what's that conversion factor? I'm going to do this off to the side, maybe over here on my paper. I'm going to have 30 degrees times pi over 180 degrees. Remember, I multiply by pi over 180. So I get 30 over 180 pi. They can both be divided by 0. Divided by 10, I'm sorry. So the zeros cancel. And I'm left with 3 over 18. And they can both be divided by 3, so I get 1/6 pi or pi over 6. For right now, I'm going to write this as 1/6 of a pi. You'll see why I'm leaving it as 1/6 pi as opposed to pi over 6. Now remember, we said that these two angles should be supplementary. Notice 30 and 150 add add up to 180 degrees. Now the equivalent of 180 degrees in radians is a pi, which means this angle and this angle should add up to an entire pi, which is why we did the drill that we did this morning. If I have 1/6 of a pi, how much of a pi must I have here in order to have an entire pi? Well, this must be the other 5/6 of a pi, because 1/6 of a pi and 5/6 of a pi gives me 1 whole pi. Then I have to think to myself, when I go along a straight line, I add 180 degrees, which is the same as adding 1 whole pi. So here I have 1/6 of a pi, and I'm adding 1 whole pi. 1/6 plus 1 whole pi gives me 7/6 of a pi. Because remember on our drill when we said 1/6 plus a whole, which is 6/6, is 7/6 of a pi, which is why we did that on our drill. Here I have 5/6 of a pi. I'm adding a straight line, which is 180 degrees, or 1 whole pi, which is 6/6. 5/6 plus 6/6 gives me 11/6 of a pi. So let's review that. These two together must add to a whole pi, which is why I have 1/6 and 5/6. Then I'm going to add a pi. 1/6 plus 6/6 is 7/6. And remember, I can just think add numerator and denominator, 7/6. Add numerator and denominator here because I'm adding a whole pi, 11/6 of a pi. So the only conversion that you have to do is that first quadrant. That 30 degrees times pi over 180, you get 1/6 of a pi. That then allows you to easily find the other radians without having to do any conversions. Now we also have to fill out the ordered pairs here. And this is where it's important that we know our special right triangles. Now most likely you are going to end up, from us using this so many times, memorizing these ordered pairs. But for right now, I've got to think to myself about my 30-60 right triangle. So I'm going to draw that down here. The 30 is across from the shorter side, the 60 is across from the longer side, and this is the hypotenuse. Across from the 30 is 1, across from the 60 is the square root of 3, and the hypotenuse is 2. So for that first ordered pair right here, where I'm looking for the cosine and then the sine, the cosine of 30, cosine is adjacent over hypotenuse, square root of 3 over 2. So this becomes square root of 3 over 2. And this one here is the sine, which is opposite over hypotenuse, which is 1 over 2. So I have square root of 3 over 2. I feel like that's a little bit hard to read. I'm going to make that just a little bit bigger. Square root of 3 over 2, 1/2, and this is cosine and sine. So we have square root of 3 over 2 and 1/2. Then I also want to find my tangent. Tangent, remember, we said, is sine over cosine. So the tangent is going to be 1/2 divided by the square root of 3 over 2, which is 1/2 times the reciprocal. Oh, sorry, I'm not showing you my work here. Sine over cosine is tangent. So 1/2 times the reciprocal, the 2's cancel, and I'm left with 1 divided by the square root of 3. But I'm not allowed to leave a square root in the denominator. So in rationalizing the denominator, I multiply by 1, because the square root of 3 over the square root of 3 is simply the number 1, and I'm left with the square root of 3 on top and just 3 on the bottom. So my tangent is the square root of 3 over 3. Well, remember what we learned. We learned that all of these have the same cosine, sine, and tangent. The only thing that's going to be different is the fact that this quadrant over here is my negative, positive quadrant. So these are all going to be negative, negative, negative. And these y coordinates are positive, which makes my tangent negative, negative, negative. Down here in this quadrant, this is my negative, negative quadrant, negative, negative, which makes my tangent positive, negative, negative, positive, negative, negative, positive. Because both x and y are negative, that's why I put all those negatives there, is going to give me a positive tangent. This quadrant over here is my x is positive, my y is negative. So positive, negative, positive, negative. I'm not writing in the positive inside here because it gets a little too crowded. Positive, negative. Since these are different, this ends up being a negative tangent. Okay? So now all I have to do is fill in these ordered pairs. So square root of 3 over 2, 1/2, square root of 3 over 3. Same thing here, square root of 3 over 2, 1/2, square root of 3 over 3. Same thing here, square root of 3 over 2,